Bismillahirrahmanirrahim. Assalamu alaikum. My name is Hasib Zafar Siddiqui. I am currently studying in 8th semester in Computer Science Department at Sakraibia University. So the project on which I'm going to deliver presentation today is traffic sign classification. Let's begin with the introduction of it. Traffic sign classification is a process of automatically recognizing traffic signs along the road, including speed limit signs, yield signs, merge signs, etc. So the dataset on which we are working are composed of the 43 different classes and they all are images. And the length of the data set is almost 40,000 to 50,000 images. Now we are using the convolutional neural network for the classification of the images. And for that, we are using the module TensorFlow and Keras. TensorFlow is a low level API and Keras is a high level API. Now, the problem statement. So the problem statement is that we as human beings do a lot of mistakes while driving cars. We usually do not care for traffic signs, which in result causes a lot of damages. You can also say that it is need of autonomous car. They have to learn it too. Traffic sign recognition is an important problem for autonomous cars and drivers assistance system. So for that, traffic sign classification is proposed, which helped the autonomous cars as well as us while driving to prevent any accident. So with recent developments in the field of machine learning, high performance can be achieved, but typically at a large computational cost. So this is all about the problem statement and also the introduction of the project. Now I want to explain you the code. So let's go to the code portion. So in the start, what we are doing, we are, which is the most important thing, libraries. We are importing the libraries. So we are importing 7 libraries. Number one is matplotlib, which is a data visualization, or you can simply a visualization library, and we are also use it in visualization. Then we are using numpy, and it is simply on, by using the numpy we can apply different calculation, and we can also make the calculations like for normalization of the image and also the conversion from RGB to grayscale. Then we are using the TensorFlow library, which is you can say the most important library right now, because by using it we are going to make the convolutional neural network. After that we are using the pandas libraries. Then the seaborn is also like almost same like matplotlib. It is also a visualization library. Then we are using the pickle library. We are using pickle library for loading the dataset, because the dataset which we are using, it is deserialized and it is a .p extension file. So for that, to make it serialize again, the pickle is used for serializing, deserializing of the Python objects into the byte streams. So we are going to use here, we are just only using it to load the data set. And then we are using the random library for random functions, because we have to pick randomly any index to show the image. Now let's jump to the next portion. The next portion is that how we are loading the data set. I already have a folder named traffic sign data, and it has train, valid, and test. Now I want to tell you that how actually we have divided train, valid, and test. We have distributed it in 60, 20, and 20 portion, although many of the developers divide it in 80 to 10 and 10, or sometimes they do not use validation part, they directly jump to the test part. But we are using here validation, so we have distributed it 60, 20, and 20. You can see it in the image too, this one. So why we are using it? Simple. Training set used for gradient calculation and weight update. Validation set is simply for cross validation, which is actually helping us to see that how our project or model is working while learning. And the testing is actually the unseen data for our model, which we use at the last for check that whether it is predicting the perfect one or not. So here we simply load it by using the pickle load. You can see here what we are doing, pickle.loaded, and giving that training data which we have loaded here. And we are using the mode RB, which means we are using it at reading and writing form mode. Then once we are getting all of them, like training, validation, and testing, we have done these with all three of them. Then we are jumping for get extracting the features and the labels. It is having two columns, you can say. One is for features, and feature is a column having the images, and labels are the simply the label, the classes which are telling us that which image is what. It's simply labels are one, two, three. These all are the labels which are identifying, and how to identify. Let me show it to you. At the last, I am having the whole description. See, these are the numbers which, if because our model is going to predict only numbers 0, 1, 2, 3. These are the classes, but for that we can directly jump that 0 means speed limit 20 kilometer, 1 means speed limit 30 kilometer, like that. If our model predict 12, it will be priority road, etc. So, like this we are using the classes. Now go to the portion again, and let me go to the portion again. Now see what we are doing. We are simply seeing the shape of it. It is showing you 32, 3, and 34,799. There are 34,799 rows. You can simply say that is these are the number of the images. And 32 by 32 is also is showing the length and the height and the width of the image. And the 3 here, the dimension is showing that it is an RGB, because 3 RGB, red, green, and blue. And when we go to the white trend, these are just labels, not the images. So they are just showing that number, that how many they are in total. Then what we are doing, we are simply doing the image visualization. We are using the random function here. We are randomly picking any index from the length of the xtrend, which we already know, which is 34,799. And it is picking any index, and then we are using it in xtrend and plotting it. So you can see that how we are using the matplotlib here for visualization. Now we have just print one. It's time for us to print many images, like we have to subplot them. So for that, you can see here we have used wgrid and lgrid. I'm going to tell you why we are using it. Here you can see that we are using the pld or subplots, lgrid and wgrid. It is actually showing the you can say the length and the width and the height of the whole, you can say, the plot. Like here you can see we have 10. It means in the row they are going to have 10 images, and in the height it is in the column it is also going to be 10. And we are using the size of the figure 10 comma 10. After that we are flattening it, matrix into 24 25 10 to 10. What means it would be 100. Sorry, I did not change it. It was a comment. It would be 100 array. Now we are getting the length of it, and what we are doing, although we know that in length and the width there must be 100 images. That's why we are multiplying them. 10 into 10 equals to 100. And one by one we are picking up the images. Here you can see index input on random, we are randomly picking any image. And then we are also getting the, you can see, white rand. White rand, what is white rand? It is a label. So here through this white rand and x rand, we are getting the image and also the label. You can see we are printing the labels as well as the images, and we are using h space of 0.4. So it is giving the spaces, height spaces between the images of 0.4. So you can see 10 in the rows, 10 in the columns, and all the images are there, 100 images, and with their labels. So this is also, you can say, a part of the visualization. Now, time to convert the images into grayscale. How we are doing it? First of all, we need to shuffle it. We are using the shuffle library. Why we need shuffle? Because we don't want our model to learn like starting 10 or 0, then after that till 10, it is 1. That's why we are shuffling it. So our module will be more intelligent. It will not make any sequence. It will not make any pattern like that. The starting one would be that, and after that would be that. So that's why we are shuffling it in order to make our module work more perfect. Now you can see what we are doing. We are simply, it is RGB. So RGB consists of three colors. So we are simply averaging them, and also we are keeping the dimensions in order for us to see it here. I'm going to explain it to you. So what we are doing, we are just summing it up. We are taking the average of all three of the colors, and it will become the grayscale. That's how we are converting all of them. Which one? The extend, extract, and extest, sorry, and the validation. These are the gray ones. Now, what we are doing when we are calling the shape, it is almost the same which we call extend shape, but it is having only one. Why? Because it is converted into grayscale now. Before that, it was three, which were indicating that it is having three colors. Once we have done it, now it's time for us to normalize it. Now, why do we normalize images? Actually, normalizing images, data normalization and images normalization is an important step which ensures that each input parameter, means we are having pixels here, has a smaller data distribution. This makes convergence faster while training the network. That's why we are normalizing it. For that, what we are doing, we're just minusing 128, we are subtracting, sorry, 128 and dividing it by 128, and so that we are simply normalizing the images. And when we print it, now you can see it is less than and zero, and not before that it was 100, 20, 25, 255, like that, but now they are less than zeros. It is normalized now. Now we are just simply visualizing it. Number one is a gray one, then simple color one, and the normalized one. So this was a gray one, it is a colored one, and this is a normalized one. We have visualized all of them. Now it's time for us to make the convolutional neural network. First of all, we have to understand what actually convolutional neural network. It actually takes any image, and on that, what actually it does, it makes the convolutions of it, and also it uses the kernel for that for the feature extraction. Once it is done, it start making pooling. What actually happened in the pooling, it you can simply see that it is smaller in size, so we are extracting more data from it by making the pools. After that, we use flattening. What flattening do? Flattening compile all the poolings together at one and send it to the input layer. Then it is go to the hidden layer, and they all are connected with each other, which means it is a dense layers. Dense means that all the, means you can see here, it is one neuron which is connected to all the neurons before it. So that's called the dense. I'll show you the code too. I already explained you all the things. I'm going to tell you in the code, and then the output, it will tell you the output. There's also one thing. It also use downsampling in pooling. Downsampling and convolutional layer. Here we are also using an activation function which is relu. I'm going to explain it to you. Here you just see the graph of it, that it is not in negative. Just simply see. It is not in negative. It is either 0 or greater than 0. Now dropout. Why we use dropout? Simply, it improves the accuracy of our model. Dropout is a regularization technique. Sorry, regularization technique for reducing overfitting in neural network. What actually happened? Our network become dependent. The neurons become dependent upon each other. That's why you use dropout for clearing their dependency. It's like that you are drowning someone on the in sorry, we are you can simply say making something down in order to make it more stronger. It's like that. That's why we randomly drop some of the neurons. Now this is the code. Simple. We are using the TensorFlow and Keras is the upper layer. Here TensorFlow is 2.0. That's why we are using TensorFlow with Keras. Then we are using a sequential model. Sequential model means that the output of one thing will become the input of another. It is a sequential way, like this, that there are, for example, there are four things. One gives the output would become the input of another. The second output becomes the input of the third one, and the output of third one becomes the input of the fourth one. This is a sequential manner which we are using. Then we are making the layer, this convolution 2D layer, having a 6 convolution and 5 by 5 kernel for extraction. for feature extraction, and we are using the relu function. Relu function is like, I'm writing over here, it's like a function having 0 comma max. It's like that if any number comes like -1, it will give you the 0. For example, if -com is coming, it will give you the output 0. But if the number is 30 or greater than 0, then it will return you the exact number. So through that, we are actually making it work much more better. So after that, what we are doing, we are applying dropout. I will explain you the dropout, why we use dropout. We are using 0.2, it means 20%. And then we are making another layer, which is having 16 convolution, having 5 by 5 kernel, you can say matrix, the feature extractor, and then the activation function again relu. And then we are getting the average pooling. The upper side, we get the average pooling, which actually extract more features, and then we are flattening them. I already told you about the flattening. It is going to combine all the rich point ones and give it to the input. Then we are having the dense layer. I also told you about the dense, what actually happened, that every neuron is connected with the previous all the previous neuron with it, that's the densely connected with each other. So first of all, we are giving them 120 neuron, and again using the relu function, and then 84, then again using the relu function, and at last it is our output layer. It is having 43. Why? Because we have 40 total 43 classes. That's why we are using here 43. And the activation function is softmax, because we are having more than 2 classes. That's why we are using the softmax function. If it is a binary, we might be using the binary function. Then what we are doing, we are just printing the summary of the model. You can see the whole summary. It is showing all the things which we have done before. Okay, now compilation. For compilation, the optimizer, what is an optimizer? Optimizer is actually for finding the solution for the cost function. It actually minimizes the cost function. It it finds the best parameter for error rate. Means if your error rate is very big, it will make it very less. It will find the best parameters. And we are using Adam here, which is, you can say, which can be used instead of the gradient descent. And we are using sparse category cross entropy as a loss here, because we are having more than 2 classes. If it is not more than 2, it is 2, then we might be using the binary cross entropy function, I guess that it's like that. And then the matrix for accuracy. Then we are fitting the model. Once we have compiled it, then we are fitting it by sending the gray normalized image with its label. The best size of 500 means it is going to pick 500 images at once for training. And then we are using the epochs of 45. And now we can see that epoch is the terminology used in machine learning to indicate the number of passes to train the whole data set after the machine learning algorithm gets completed. So it is an iterative one. Now come to a verbose. Verbose is equals to one. Verbose is simply the, you can say, the text which is shown here. So we are going to have only one uh, description. You can say that's why we are using one here. Then we are sending the validation, that which is very important, which here for fitting the CNN here, because we already use the CNN model. So after that, now come to the metric, confusion matrix. You know what actually confusion matrix give us? It also shows us errors, type 1 error there, type 2 error there. We can also find out the accuracy of our model with it too, that how many it has done perfect and how many it has not done perfect. Like here, the predictive one is true and the true one is true, but here predictive one is true, but actual it was false. That's why this is error. So this is a confusion matrix. Now let's jump to, now we are evaluating here, and which is going to show us the accuracy. We are evaluating the model based on the test data set, which is unseen for it. And then we are showing the accuracy. It is 90%. Our model is giving 90% accuracy. And the history variable, now we are using the accuracy, validation accuracy, which is actually stored in the history variable. And for that, through that, when we visualize it, we can come to know that whether our model is going overfitting, underfitting, or it is going perfect. Now you can see when we visualize it, our model is going nice. It is not overfitting, it's not underfitting. When it is going to take all the dots over here with the line, it will become overfit. If it is very much away from it, it will become underfit, but it is not very much away and not very much close. That's why it is fine. Now we have the prediction. We are predicting extra square normalization. We are actually sending all the test images, which we got the 20% data, and we are predicting it with our model. And also we are using the y true test, means this is a true one, and this is actually the one which in the predicted class is the one, the output which is the predicted one, and the y true is the output which is the actual one. Then we are using the matrix, confusion matrix, and we are plotting by using the CNS, which I told you that it is also data visualization. It is also a visualization library in Python. And now you can see the whole confusion matrix is here. It has almost done very nice work. You can see one is with one. There are one for, you can see there are 42 because it is starting from 0 to it will be 43. You can see 1 to 1 they are a mapping. It is actually mapping all of them and giving you the perfect model. Now it's time to plot. Now you can see that we have plot the accuracy one. See, we have already predicted the classes before when we were about to use the confusion matrix. Now it's time to plot them. What we are doing, we are again making the subplot, but this time it's 5 by 5, but the image size is 12 by 12. Okay. So I told you that we got the prediction one and also the real one. So we are using both of them and also the image. Here the prediction is 16, the true one is 16 too, and this is the image. That's how we have printed all the images. We have almost printed 25 images with their truth label and also the prediction label. Almost two of them are wrong. Like this one is true 3, but it is predicted 32, and this one 23 and 19. True one was 19, 23, and but our model predicted 19. So through this you can conclude that our model is working very perfect, because out of 23 it is out of 25 it is perfect. It is predicting 23 correct images, only 2 wrong. So this was all about my project explanation. Now I also deployed this project, and I also want to show you that how actually the deployment is working. So first we went to the folder where we deployed a model. We are inside the folder. Time to open the CMD. Now we have the CMD. It's time. I have deployed on local host, so I'm going to use the by using Flask. So I'm going to use the Flask commands. So set Flask underscore app. There are 2 commands. So I'm using the first one in which we have to set the model. The second command is used to run the model. So this is the name of the model. Now I'm copy pasting it over here. Now it's time to run it. Sorry, the command was flask run hyphen host because it is local host. So we are using 0,0,0. Now enter. Now it will start compiling it. So it will take a little bit time. So for till it compiled, I'm pausing my recording. I will be resuming it when it is compiled. So welcome back. Our module or project is compiled and is using 5,000 ports. So we are going to jump to the 5,000 port now, to the local host 5,000, and the whole link is already there because I have already used it many times. So it is saved. Now run it. Time to choose the file. I have already downloaded one file in the desktop, and it is having 50. Let's jump to the 50. Here it is. Now predict this one. We have uploaded it. It is shown over here. When we click on the predict one, the result will be shown over here. Now see, it just predicted it perfectly. It is 50 speed limit, 50 kilometer per hour, and it is also predicted that the speed limit 50 kilometer per hour. So our project is going very well. It is also deployed locally. So you can see all the things are done. So thank you so much for listening me. This is all about my presentation about the project. And thank you so much again. And Allah Hafiz.